Now we should put thing. I think we will give the expo position. Medium, right? So actually, is you don't have to use quotient rule. Understand? The general answer is this: if your term is a constant, don't need to use quotient rule. You can simply write it as 7 e to the power of 2x minus 5 to the power of negative 1. Can you just look at the board for a while? Then 7 e to the power of 5 minus 2x. This is your y. Some of you can stop here, but you must remember you haven't differentiated yet. You haven't differentiated. Okay, you're just preparing. Okay, it's just like you're laying your ingredients out, but you haven't started cooking. So from here, then you differentiate. Then that's the final answer. So far, okay? So similarly, if I have y equals to 3 times e to the power of 2x minus 5, if you treat this as u, you differentiate is also 0. Need to use product rule, no? Need to use product rule for this one. Don't need. Don't waste time. Don't waste time. Don't penalize yourself with this kind of unnecessary steps. Should they okay? Okay, so question 2.2. Question 2.2, you need to use product rule. You need to use product rule. So you all see that if y equals to x times e power x minus 3, pay attention, especially if you try to complete that all, okay? Okay. So I see that there's a u, there's a v. Okay, now we must use product rule. Okay? Then dy dx will be differentiate u multiplied by v plus differentiate v. This is dv dx. Now differentiate the f is just 1. So I multiply by x. So this one is my answer. So I got this out. Calculate the gradient of the curve at the point where it crosses the x-axis. There's a curve, it crosses the x-axis, and the x-axis, I know one thing, y equals to 0. But you must know that dy dx is always in terms of x only. For JH4, for JH4. dy dx is in terms of x. Okay, so then how do I find this point there? You might need to do an extra step. That is, use this to find x. Okay? Use this to find your x. How do I do that? Equate y equals to x e x minus 3 equate to 0. Equate y to 0 to find x. Okay? Then from here, okay, by the zero product rule, if x times e power x minus 3 is equals to 0, it can only mean either x equals to 0 or e power x minus 3 equals to 0. This is the zero product rule. Okay, if a times b equals 0, either a equals to 0 or b equals to 0. So far, okay? Now, can an exponential function ever be 0? Can it ever be 0? No. Remember, exponential function looks like this. Okay? It will always be above the x-axis. E power x. E power x, example. Not this kind. This is x. There's an x inside. There's an x times e power f. So different. Then x can constitute this one. But on its own, it's exponential. So this is rejected. There's no solution. So the only answer is x equals to 0. What does it tell you? At this point, x is also equals to 0. So this is actually the origin. So far, okay? So from here, you just need to sub x equals to 0 into dy dx. The gradient at the point where it crosses the x-axis, you sub x equals to 0 inside, then you will get your dy dx. So far, okay with this part? This part. So try to do this question about 4 or 5 times. Okay? again, try to do this question about 4 or 5 times. Okay. So with that, let's look at AFL2. AFL2. Can I just give you about 10 minutes to finish? Who has already finished AFL2? Finish already, you look at part 3 and part 3. So for the faster route, I will go through part 3. Okay. Simple set of rules. So John and Callum can listen to me. Very easy one. So we talk about log, right? Log. Okay. In JH4, when we differentiate logarithm, we are only differentiating only natural logs. Only natural logs. Okay, natural log. So the only thing we can differentiate is log. Log at the moment. Okay? Yeah, and one of the things to take note is when you differentiate log, your x has to be more than 0 lah. Because log cannot take in a negative number. So one of the things I want to first you want to consider is this one now. Sometimes they may ask you to look at the domain. You will find that some questions you will need to consider the domain. Okay, like what is the value of x? Okay, so if I differentiate log x, it's just 1 over x. Very easy one. Okay. So okay. Yeah. Okay. So why is it 1 over x? I mean, if you look at the long graph, right? At first the gradient is very high, then the gradient becomes very small. So over here the gradient is like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You look at the gradient, it's going down. But if you look at the x, it's going up. So in a way they are like inversely proportional. That's why it's like a 1 over x. As the x gets bigger, the gradient gets smaller. So this is the first formula. Second formula is this one. What about if I were to differentiate log of fx? So just use chain rule. Here, if I differentiate the outside, it's 1 over fx. If I differentiate the inside, fx differentiate is just f prime. Okay? Can this one I think is A-level formula. So we are learning it a lot of course. So these two. Can and next question is this. So what if you all are asked to always try to maybe I told you a question since you all are fast. So Callum, Josh, Mika. What if you are asked to differentiate this? What will you do? What will you all do? Do you have to like f prime then you product rule? What will you do? Sorry? Plus, you say plus? Combine. Okay. What if I do something like that? What will you do? Now the answer is very simple. Use laws of logarithm. Use laws of logarithm. So this right, that's the idea like. You always have to mix topics together. So, Helen and John can because I can write it this way. Simply because in laws of logarithm, we know that log ax plus log ay is the same as log axy. Okay? I can also write this. This is my y. As 8 ln 7x plus 3 plus 10 ln 2x plus 3. Simply because in logarithm we know the power log. Log ax power r is r log ax. Okay? So from this right, you find instead of differentiating a disgusting function, I can get simplified and easier. So one trick about logarithm is before you differentiate, apply the laws of logarithm. Maybe you will write down. Okay. Apply laws of logarithm. very common that you get functions like this, which are very long and disgusting. You must be mentally prepared. Which is why I will give you one word of advice that you try not to do it at one shot. This is what I mean by doing it at one shot. Okay, so this student, right, you see she differentiate this, right? Then she, okay, so you see this is what I mean by doing it at one shot. Okay, you will get, unless your algebraic manipulation is go ahead. I mean, go ahead, because different people got different preference. Some people, when they cook, like my mother, cook that time, no salt, then she run away and salt. Then fire still on, she go downstairs and buy cooking oil. So then when you want to cook that time, you find that you go and eat, go and that. Some people, like me, you see how you do this. I always like to come earlier and prepare one. So what you do? Okay, 60 student also. Wow, you see wow, it's really like a world map. Okay, so, but the problem is what? When she do due dates, the due dates wrong. Pass away, only pass away. So what I advise is this. You do what I do. You write out U and UDX, B and DDX. At least you get marks for this. You know what I mean? You get marks for this. Otherwise, you see I cannot find where to get marks. Very hard to mark, very hard to mark. Oh? Okay, then the teacher also see stars like in far right, see stars. Okay, so must try your best. Okay, so let me go through question 2A. So for 2A, you try, okay, you have 1 plus 3e minus 2x power 2 tangent square x, right? Let this be u, let this be v. Okay, prepare your ingredient first before you cook. If this is u, if you trust me, it's just like your house, your wardrobe. If you arrange your things nicely, right? In the morning when you want to find your dress and shirt, it's very easy one. Power go in front. Power drop by 1. Differentiate 1 is 0. Differentiate minus 2x is minus 6e minus 2x. Okay, then b is tangent square x. You can write it as tangent x squared. So it's just like eating a double McSpicy. You take it bite by bite. Bite by bite. dv dx. Differentiate outside, tangent x. Differentiate inside, secant square. See, so clean, so nice and neat. So teacher see also teacher know where to give marks. Oh, so then after that, what's product rule? Product rule? Give me 3 seconds. Faster! 1, 2. Oi! Faster! Okay, so you just take this part, then you copy out. Okay, even if you never simplify, you get the majority of the marks. Okay, ma? Okay, okay, so I'll go through the rest tomorrow. I'll go through 3B tomorrow. Okay? Can So tomorrow I'll start on part 3. Okay, thank you, class.
Okay.
Okay, so the last time round, we talked about part 1. So the quiz, the test is until part 3. So it's the entire chapter 1 chapter 2. So the first part, differentiate, we talked about differentiation of triple function. So if you remember the last, we didn't really go through this last time we touched this was last week, because Monday we were just going through the practice at all. So if you recall on Monday, last week we were talking about differentiation of triple function, then we basically also apply product rule, quotient rule, chain rule in derivatives of triple function. Okay. Then after that we talk about 3 new derivatives. Okay, which is basically we call the derivative of sine x, cos x, tangent x, as well as secant x, cosecant x, cotangent x. Unfortunately, all to memorize. Okay, so make sure you memorize them all. Okay, so all of them. Then with that, then we'll talk about negotiating different layer of chain rules. What about things like sine 5x? What about things like sine power 7 5x? Okay, so this is the main gist of part 1. So now today we will go to part 2. So part 2 we differentiate exponential function. Okay, we will differentiate exponential function. Exponential function, the idea is if you differentiate you differentiate, okay, so if you differentiate exponential function, right? The idea is, okay, you know, dy dx, in the sense, remember the first day that we learned this last year, I always told you that you always think about dy dx as the gradient function, right? Or dy dx gradient function, that's the idea, to find gradient. So if you look at y equals to e power x, right? And you look, if I would just use a tangent or use a tangent, the tangent is moving. You can also see that the gradient, right? The gradient of the tangent is also going upwards, right? Can you see it's getting steeper and steeper? So if the curve is getting steeper, the tangent gradient is also getting, can you see it's also getting steeper? So in a sense, the gradient of e power x is also going up exponentially. Okay, the gradient of e power x is also going up exponentially, which is why when you have exponential function, the gradient is also the exponential function. Or e power x is the only one in the world where if you differentiate e power x, then dy dx is also equals to e power x. So far, okay? Then what about chain rule? So what happens if we have a chain rule? So same principles, we look at it from outside to inside. We look at it from outside to inside. If I look at, so say y equals to say 7x plus 3. Okay, I will look for two layers. This is layer 1. Layer 1 is that I see e to the power of something. This is layer 1, layer 1. Okay, then layer 2 is this one. This is layer 2. Okay, layer 2 is 7x plus 3. So far, okay. So if you differentiate them, layer 1, layer 2, then differentiate layer dy dx is just differentiate layer 1 multiply differentiate layer 2, which is differentiate layer 1 is e power 7x plus 3. Differentiate layer 2 is just 7. Is that okay for you? Just show you one time. So in general, if I base on this, right, what is the takeaway? The takeaway is that if you have y equals to e power fx, okay, then your dy dx is just equals to f prime x. If I differentiate the top, I put in front, then I just copy paste my answer. That's all. I just differentiate the top, I put in front, okay, then I copy paste the answer. Okay. Okay, so with that, can you help me look at 2.1 and 2.2? Help me do question 2.1 and question 2.2. Yeah, same thing. So e power fx, fx is a function, right? Then function to fx of this here, the answer is e power fx times f prime because I differentiate this. So this is to show, because if I start teaching with this one first, it's a bit cheap, so I start with this one.